record this because if you want to come and visit, of course, we are the best located places of all the other institutes. These are pictures of Lecco. And this one is a picture of the sunset caught from the window of my office. Just for you to be aware that if you want to come, you're more than welcome. And this is what is waiting for you. Okay. I'll try. So what I'm going to talk about today is just, let's say, 3 experiences that are kind of exemplificative of the work we have done throughout years. Then I will give you a glimpse of some other activities that we did. And the last point is dedicated to future plans and collaboration, but also explain what I did here. So let's start with the first one. Here is the story of the virtual supermarket that actually started in 2015 because it was the first thing that I did for my PhD. And this was an application developed for older adults with mild cognitive impairment. And it was firstly developed for training visuospatial abilities in older adults. So they had to look around for grocery items on the shelves. There were levels of incremental difficulties because items at the beginning were just a few, then they increased in number, they increased in similarity, and so on. But it's a good example because it can show how we work usually, because we did several steps throughout years, and our aim, of course, was to purchase an increase in engagement and a sense of presence in order to improve the user experience and also to favor treatment adherence and compliance. And then we also work to improve the accessibilities of all these hubs so they can be available for different kinds of patients. So the first thing that we did was to try to develop an immersive version of the supermarket. So you can see here a video of the very first version and the very first application of immersive virtual reality that we did. Here it was dedicated once again to older adults with mild cognitive impairment. So they had to do the grocery shopping by searching items on the shelves, and of course they had a shopping list to follow. Then we got in contact with a clinic working with stroke patients, and they also were interested in implementing cognitive training for the patient, but for them, it was not safe, of course, for the patients to walk around. So what we did was to change the scenario. So you can see here, it's me doing the exercise while staying seated. And this was, of course, a way to make this application available to them as well. And what we did, of course, was trying to complicate a bit the scenario. So they also had to remember the list at a certain point so that it could be challenging enough. And last but not least, this is a further implementation toward accessibility, because these are 2 versions of the supermarket that were developed for neuromuscular patients. So this one can be interacted just moving a bit the wrist. That can also be leaned on the wheelchair, armchair. And the second one tries instead to reproduce the same functioning of ocular pointer. And so in this case, we use the head movement to create the interaction, but potentially also gaze can be implemented. And of course, in this case, what we did was also taking care of picking a technology that could be easily transported around so that can be also easily used by a patient in a wheelchair. Throughout all this experience, as I told you before, one of our activity, of course, we collaborate with clinics, so we also participate in clinical trial. But what we do mostly is to evaluate the relationship in between the human and the technology, because as you probably know, only if technology is accepted, then it's something that people will use in their everyday life. So starting from the first study, we have seen since the beginning that there's high technology acceptance, even if older adults that are usually not so familiar with technology. And the other interesting result that we got in this study was that we found a reduced level of anxiety in the activities of daily living, which even though it was not associated to cognitive improvement, had an effect on the quality of life of patients. So our work was also helpful to discover these things that were not directly reported by standard clinical tests. We also did an evaluation of the immersive versions of the supermarket. So this is the walk-in version, and we assessed the sickness because, of course, it's something that can happen. And the levels were more than okay because the acceptable range is between 0 and 20, but this course can go up until 200, so it was fine. And then there's a graph on technology acceptance. So also here, all the variables were more than satisfying. The only lower one is computer anxiety, so it's okay that it is low. And also sense of presence. Here we compared our experience with the previous one. And as you can see, the realism was really satisfying. And we also noted this because we had an adverse event in this trial because one of the users fell down. And he fell down because he was tired and he tried to lean on a shelf, which of course were virtual. So of course we were sorry for him, but on the other hand, we said, okay, yeah, that's really realistic. So good for us. Yeah, the same, more or less the same variables were evaluated for also the seated version. Also here, we evaluated the variables at the end of the training period, which lasted 1 month, and at the end to see if something changed. And what we were particularly interested in was in seeing if the engagement was kept high during the whole period, meaning that indeed virtual reality can induce motivation and better treatment adherence, and this was the case. These are just 2 of the scales. We are currently writing this paper, so soon all the results will be available. And also the other interesting thing of this trial that we did with patients is that we were not expecting for any motor outcomes to improve, even though, of course, there was a training of the reaching movements, but we did find some improvements in a month. And it was great because these were mostly chronic patients. And we found improvements in the balance, Berg balance scale, box and block on the affected arm, and motricity index and time up and go test. So, well, it was really a satisfaction for us that we could achieve something also at the clinical level. And last but not least, just to say that the virtual supermarket has also been used as an excuse also to study how people move with their upper limb while reaching object in real versus virtual world. So I also did this study during my PhD, reading a lot of Mindy's paper and work. And well, we saw that more or less the movement, even though if it was lower, the synergies were more or less preserved. So this was a good point. Okay, this is the second little short story that I would like to present today. Also here, we started with a 2D version of this virtual park that was initially developed to support the physical exercise, so cycling. And it was just there as a distracting element because of course, we needed to engage older adults in a sport activity, and most of them were not so happy with this. So this was a way to try to get them a little bit more motivated, and also an excuse to monitor their performance through the heart rate. But also here, starting from this initial scenario, what we did was to try to increase the engagement throughout time, and also to make this platform a little bit more accessible for all patients, and also in different settings. So as the first thing, what we did to increase engagement, but also a little bit subtly to get some cognitive training going on, we introduced cognitive tasks that are helpful on a hand to, of course, train cognitive abilities, but also on the other hand to implement, something that can be even more engaging and therefore even more distracting from the physical effort. So here you see some of the characters and the tasks that we have implemented through time. In the first case, you have to recognize all the animals whose name started with a specific letter. In the second case, so the three central pictures, there was a go, no go task in which people had to kill monsters and save animals. And the last one is the most difficult one, because depending on the color or the arrow, you have to press the button. So if it's red, you have to press the button on your right. Otherwise, if it is blue, you have to press the button on your left, even though the arrow point is pointing always right. In order to increase engagement, what we did starting from this environments implementing cognitive task was, well, we are still working on this, but the architecture is now built. Developing a social version, so people in a remote location could decide to train together, either collaborating or competing. So in this case, of course, you need an internet connection, and the setup gets a little bit more complicated. But the idea is that different people with different abilities can get the training. And of course, there are adjustments depending on what is the physical and the cognitive effort that they could do. In terms of accessibility, instead, we developed a system that could be transferred quite easily to home. Well, of course, moving a cycle ergometer that is heavier than me was not that easy, but what we did was integrating our application in an existing telerehabilitation platform, a commercial platform from Italian company. So in this way, we can exploit all their infrastructure working via internet, and also we were compliant with data storage and so on. And we also did a study that just finished, and we enrolled different types of patients in this case, and we delivered the cycle ergometer to their place for 4 weeks. And they were prescribed a quite intense program of training, because it was 5 times a week, 20 minutes, twice a day in most of the cases. And what we did here was once again assessing what was the acceptance of technology, and if having this technology at home could somehow influence the attitude toward technologies of all the participants of the study. What we noticed was that in most of the cases, the attitude remained stable, meaning that we have no disrupted the relationship with technology. And also acceptance was different across the 3 groups of patients, but more or less levels of acceptance were satisfying, even though, of course, with a system that is not immersive and it just as a screen, of course, engagement levels are not so high as with immersive virtual reality. And in terms of accessibility, this is another working project, but it's a big project that is now going on, and we will perform 2 clinical trials soon. We are integrating this ergometer that can be used both with feet or arms, depending on the needs of the patient. And it also provides an assisted cycling, so it can be used with by patients with additional limited mobilities or issue or whatever. Going on to the third story, here I put something on a wheelchair simulator that we developed. And this is the result of project that ended in 2020, but now we have started again working on our wheelchair simulators because we got a second project on this. And what we developed was a configuration environment that allowed the clinician or the therapist to set up 3 different training environments. One that was outdoor, one was a home-based environment, and a third one was a office. This configuration environment was based on the skills that are assessed via with the wheelchair skill test. And also in this case, we built actually 2 systems. The first one integrating our scenarios in a Grail system. So in this equipment that is from Motec, a Dutch company, and which foresees a semi-cylindrical screen and a treadmill that could also be inclined. And on this device, we also, in this case, we simulated just the electric powered wheelchair. Sorry, okay. And in this case, we also did a very preliminary study enrolling 10 novice and 10 expert users of wheelchair. And what we found were, well, different results in the usability of the environment, because the novice user preferred the outdoor and were also more efficient in open spaces, whereas home was prepared from experts, maybe because it was a little bit more challenging, so they could, well, they find it a little bit more engaging. The real prototype of the study, however, of that project was this one. I'm sorry, I didn't want, I just want the video to start off. There's no way I can do this. Okay, well, I'll show you this. We actually built up this prototype, which is a very complicated and big and heavy prototype based on a Stewart platform. Here you can see that my colleague is pushing on the wheels. Wheels are actuated, and we are using an immersive virtual reality system and data gloves to track the hand movement and to implement the interaction with the environment. On the left side of the screen, you can see what the operator sees on the 2 monitors. So he also has the chance to see all the tasks that the user has to do and to start or restart them if they are not carried out correctly. There is also a joystick, so there's also the chance to simulate powered wheelchair with this simulator. But of course, well, we are still waiting for the validation of this simulator because it's kind of a mess with the new medical device regulation to get the approval. But in this new project, we are working on it. What we are doing additionally in the new project is to try to develop a more portable system, maybe, well, for sure, getting the help from a company And also what we would like to do is to improve our training environments by means of studying a little bit more how embodiment could influence the learning of new skills. So you see here some of the environments that we are developing now for doing this study. The first one simulates the first-person view of a walking or instead of pushing a wheelchair. And the second one is to test reaction times in different parts of the body, because it has been shown that wheelchair users are more reactive in their sensitive parts of the body, but also on the wheelchair if the wheelchair is theirs. So we would like to try to redo and rebuild this test in virtual reality and see if it works. And yeah, this is, no, I went on too quickly. There's a little delay in my slide going. Well, these are just example of the application that we developed for children, because I've never mentioned that, but we have also a collaboration with children. The first on the left side that you can see is dedicated to children with cognitive disabilities who have to learn the needs of the other people. So the character is going on in different situation, and the child has to pick what is the right thing to be used in that scenario. The second one is for having food related, to get some food related information, because we saw that some children with disabilities sometimes have not such a good diet. So this was for getting some indications. And this on the right side is the first attempt that we did to build an immersive virtual reality scenario for children, because of course there's the issue of having a heavy and big headset maybe on a small child is something that may not be so easy. And this is specifically an application for attention deficit hyperactivity disorder. And here the task is to pay attention to the objects that appear on the blackboard. This is the training phase. To the object that appears on the blackboard and keep the eye fixed on it. And then there are some distracting elements, and then there is the search of the object in this living room. We have just ended the usability study on this, and we saw that it's not that easy to implement immersive virtual reality in children, especially if they have attention disorder, because they kind of move around very quickly, and it's difficult to keep them focused. And instead, these two are videos of applications that have been developed not with a rehabilitative purpose, but instead to provide a support to study neuroscience or human behavior in general. This is a task that the avatar is doing. Is kind of an easy task, but what we introduced is a distortion of perception. So first, the task is done as in real reality, so looking at the objects that the user has to move. Then he or she has to look in a mirror and do the same task without seeing what's on the table. And finally, the third step is to look in a mirror, but the mirror is inverted, is swapped. So it's kind of difficult, but the idea is to coupling with EEGs and other measurement to see how our brain maps this motor action and motor learning. And instead, this one is an application on risk-taking. Here, the task is to swallow the balloon as much as possible. And the bigger it is, the more money you earn. But the balloon could also explode, and you don't know when this happens. So what the researchers of University of Pavia here wanted to see if there's an effect of embodiment and sense of agency on the risk-taking decision. So we are doing this in several conditions. So one acting on embodiment. So you see yourself doing the task and you see someone else doing the task you're doing. And the other one on sense of agency. So introducing a delay in between the action and the response of the virtual environment. Last but not least, this explains what I'm doing here. Because a while ago I contacted Philip and we both were a lot interested in this haptic device that was developed by an Italian company based in Milan, because for me it was really the first device that was satisfying in terms of providing haptic feedback, being a wearable device. And also this one is able to return temperature feedback. So you can have the feeling of touching a hot object or a cool object. And everybody is saying cool is very cool. So it's nice. And the idea is to integrate with this device with an immersive virtual reality environment that can somehow create a multisensory experience that can be helpful for rehabilitation. But what we decided to do first is a validation study. And so now we more or less planned what we are going to do. But our idea is to see the behavior of this device in several conditions and see if indeed the fact of having haptics is relevant to movement kinematics and in general human behaviors. So we are now planning all the conditions, which are quite a few, so we will see. But we want to make a test in real world versus virtual environments versus augmented reality scenarios, meaning that you can see the real reality also in your virtual environment. Of course, we want to test the condition of haptics and without haptics. And the idea is to test different grasps strategies. So, well, of course, we will do first a test with healthy adults with the support of our kinesiology students next winter. And we will measure some kinematics and maybe some variables related to the subjective experience. Yeah, this video is fun because now here there's like this fail because the bottle is not grabbable, but I'm quite sure that the final prototype will work. So yeah, this ends my presentation. We are going to collect the data next winter. So if anybody has some suggestions or ideas, we are more than welcome. And this ends my presentation. So thank you very much for your attention. And just give me the chance to say thank you to everybody here, because my 3 weeks here have been amazing and really the time flew. So anytime you want to come to Italy, you're more than welcome, and I will be more than happy to have you there and to, well, return what I got here. So.
Thank you, Sara. So can you maybe stop sharing your, yeah.
Yeah.
Oh.
Did it stop?
Yeah, it stopped, but not, yeah. Not really. I have a background.
Let me go back to Zoom. No. I don't know what happened.
If not, you can just close your presentation. And did you stop sharing your screen?
Yes. Let me see.
Yeah. I think it's frozen or something like that. I still see your background. Oh, there you are.
Okay.
Oh, so it's me then. So if maybe we should start on Zoom. If
okay.
People have questions on Zoom, go ahead and ask Sara.
Do I have to switch on my... Okay.
No questions on Zoom? Oh.
Okay. Thanks, Filomena. Yes, I think there's no problem in sharing our application. I have to talk to the clinician with which we developed the application, but for instance, the one on alimentary instructions has been already shared with a Brazilian group who is working to translate it into Portuguese. So I guess that there is no problem. And this gives me the chance to say that most of the work that you have seen is our intellectual property. So we are happy to share it also for free. So feel free to ask me. There's my email at the end of these slides. And also you can Google me if you want. Any more questions? Is there a French version? No. Sorry. Yes, it's definitely possible to implement some language variation. Of course, with the Brazilian, we sent the application to them, just a project, and they are now doing the translation themselves. We can also work jointly, but definitely there's a chance to do this. It's a little bit more complicated with this application, maybe just because there are some audio also, but of course, everything is doable. I see that Krista has raised a hand.
Sorry, I'm being lazy to type in the chat. Thank you, Sarah. It's a really great presentation. It's awesome to see all of the different applications you're using with virtual reality. My interest is in the children and the wheelchair simulator. And is there any concern about using screens in kids? I know there's some concern about the screen time that kids have. And is there any concern that you've heard of for having kids in virtual environments?
We have always tried to keep the experiences very short, also based on clinicians' suggestions. What we did was to implement the two experiences that were deployed on tablet were thought to be carried out together with a parent or a caregiver. So the child could be somehow guided throughout this experience. And yeah, well, we saw that most of the children enjoyed the experience, but we actually didn't explore in-depth concerns related to, well, using technology, but it was less than 20 minutes in both cases for the experience. Yeah.
Great, thanks.
Thank you. Oh yeah. Do you have a plan to? Okay, thank you for that. For the uptake equipment that you showed, I wonder if it is not too bulky. Do you have a plan to develop a glove instead? Then can be more ergonomics. Well, we are not. Let's say my group at least does not develop any physical device, and so we have a robotics group, but their focus is on something a little bit different. What I can tell you is that yes, it is a bit bulky, but when you tried while being immersed, this is not so disturbing. And also the other important information is that this company that has developed this device is now releasing a second prototype, and this new one is a little smaller. And also it provides the feeling of all the four fingers. So also the fingertip add-on is reduced in size and in weight. I saw just a picture. But it seems promising. So I think that technology is evolving toward having more miniaturized device. Okay. Fred, the research with the wheelchair, how did the virtual reality capture the movement of the wheelchair? Is it like a cadence sensor on the wheel? Well, we implemented a protocol with ROS to exchange data in between, in the case of a manual wheelchair, the actuators that are mounted on the wheels, because these actuators were also, of course, sensorized, and that there was a two-way communication in that case, because, well, of course, what happened in the environment influences how your push is difficult or not. And on the other hand, if you are moving, we need to know where you are going. And well, the same was done with the joystick. So hope this answers your question. But yeah, it was a protocol that we implemented using ROS, the robotic operative system, I think. If I can. Okay.
Yeah, and in the part, the virtual part, what kind of feedback were you providing to users? Like, did they have what exactly did they have like a score, or did they have what were they told to do, and what information did they receive about performance?
Okay, the question, just I repeat it for Zoom participants, was that what kind of feedback was provided to the participants of the virtual park? That was really dependent on the application, because we had a few versions. In general, there was an indication on the velocity they had to keep, because they had a target velocity. Well, in most of the cases, we told them, okay, you have to stay in between 50 and 60 revolutions per minute, because then we acted on workload to make the exercise more or less requiring in terms of physical activities. And then in most of the cases, they have feedback if the answer is correct or not when they respond to the cognitive task. In the social version, they have the chance to talk also. There's kind of a chat implemented. And in that case, it can be also the other user. There's no feedback, but maybe the other could be the one saying, okay, this is the correct answer, good for you. And at the end, of course, they have kind of a final score on their cognitive performance at the end.
I'm going to go.
Okay.
So I don't have to repeat my question. Thank you very much, Sarah, for sharing the various interesting applications with us. I also have a question related to the virtual park. Did you measure motivation, engagement along with the work that's performed? And is there an influence due to whether it's a tablet in front or a big screen, like the immersiveness of the technology? Does it affect engagement and motivation along with the work performed?
Okay, we did a study on this, but just on healthy participants, so no patients. And we had a comparison on in a situation in which there was like a big screen versus immersive virtual reality with and without cognitive task. And what we noticed was that well, the questionnaires were more or less the same. Also, the there's an perceived exertion scale, Borg scale. And they were more or less the same, and we got the same results for all the conditions. But when using immersive virtual reality with the cognitive task, what we saw was that the physical performance were better. So they kind of exercise a little bit more while perceiving less effort.
I'm also wondering your take-home version. So there's like the tablet, right, installed with the bicycle, the ergometer, or these days, like the smart TV, you can actually project things on a bigger screen. So would that make a difference?
Well, we have never tested this. the thing is that with this ergometer, you had a USB cable to connect to, so it would be a little bit more complicated to have the smart TV in your house connected to a laptop that gets the result. So that's why we picked the laptop. But yeah, it could be interesting also to test different screens.
What about first person versus third person view? Like yourself going into the park, or are you following yourself or an avatar?
We did not do this, but we read some studies because we are developing these collaborative versus competitive versions, and it seems that having someone else in the environment was maybe going a little bit faster than you provides you with motivation to try to keep ahead.
Thank you.
Thank you.
Thank you.
Thank you.
Very interesting presentation. I am wondering, you mentioned in the home training, right, for the bicycle, you just referred to that. You said that they did not express negative comments towards the technology or whatever training was done. Like, what about the opposite? Like, did they express satisfaction? Did they see, or did you ask?
Okay.
That, or did you ask whether they themselves felt stronger, better?
Okay.
etc.?
Okay. Just let me repeat the question. Well, it was about the home-based training with the cycloergometer, and if we had negative or positive answers of the feelings of the patients. Well, I presented it very quickly, but I must say that we have had different feedbacks from different populations, because in that study we enrolled patients with stroke, of course, at a high level, post-COVID patients, and children with cerebral palsy or paraplegia. And what we got was that post-COVID patients were the happier ones. Because they also trained more with respect to the prescription. Children were, oh, my laptop is running out of battery. Here. Okay, and children were the most critical ones. This may be related to the fact that also they were the ones they perceived the more physical and cognitive effort. But yeah, sorry.
Yeah.
It's not charging, really. No? Okay, well, otherwise maybe we can, no.
Okay.
Okay. Maybe it's the adapter as well. And post-stroke patients were in between. So yeah, it's really dependent. We also performed a study in Poland, more or less the same, with immersive virtual reality and post-COVID patients. And in their case, the feedback was very negative. But most of them were overweight, so they found the exercise so exhausting that at the end they did not appreciate anything. But it was not on virtual reality.
Did they have any coaching while the training was happening? Or?
They had the first coaching and training session at home, and then they had regular calls from the therapist. Like, well, it was once a week, so 4 times, but of course they could call in case of issues, because yeah. Thank you. Yeah, now it's
Now it's charging?
yeah.
There is one question on Zoom, I think.
What is the level of engagement of older people for virtual reality masks? There was an issue with dizziness and nausea for this age group. What is the latest development to address this issue? In our case, we have never found any issues. Instead, they appreciated the experience. In the study that I showed you with the older adults with mild cognitive impairment, that was a study focused on assessing user experience. And if I remember correctly, we enrolled 58 older adults, and just one left because she said that, oh no, this is too much for me, I don't feel okay. But all the others appreciated the experience, even the one who fell. And in most of the cases with these environments that are not navigational, but in which you can go around, dizziness is the most present side effects. But I would say that still it's in the acceptable level. And we found that older adults were more open than we expected to these new technologies. Okay, I see no other questions. Okay, well, I'm available via email, so if anybody wants to contact me again. Also, the people who asked for sharing the application, please contact me because I will never remember, sorry. But yeah, I'm open to share.
Well, thank you. Thank you everyone on Zoom. Oops.
Sorry.
Yes. Thanks all for coming. Oops.
And also the audio.
The volume, yeah. And yeah, we'll see you soon in our next talking research presentation. Thank you very much. They're saying grazie mille.